All right, so let's talk about batteries. Hopefully, most of you guys know kind of what basically a battery is, but let's talk about the technical version of it. And so, a battery is a spontaneous electrochemical cell used to drive non-spontaneous reactions. Right? You have a battery, you plug it into your little Game Boy or whatever you're using, and the battery is releasing energy. It's going in a spontaneous direction to drive some kind of work. And so when we're talking about batteries and kind of current day stuff, there's a huge demand slash need for not only just more batteries, but better batteries. Huge area of research, really cool stuff, good thing to get into. And so if you think about it, we actually have plenty of sources for green energy. Right, we've got solar, we've got wind, geothermal, all kinds of different green sources of energy. But one big issue with them is that they're intermittent. And what that means is that they're not always providing energy. So, for example, the sun's not always shining on a piece of land. And so it's not just enough to be able to generate that energy, but we need a way to store it. We need to take the energy during the daytime, be able to store it, and then be able to use it during nighttime. Or, take the wind energy and be able to store it and use it on a day that it's not windy. So we need a way to store it. And that's the point of batteries. Batteries store energy that we can then release when we need it. So here's just like on the left, a little picture of an old school battery. I think this is like one of the first ones, looks like 1904. So you can see batteries have been around for a bit, but there's still a huge demand to get them better. So you can see what that looks pretty cool. So there's kind of two main types of batteries. There's what's known as a primary cell and a secondary cell. In a primary cell, it is non-rechargeable. So it's single use. You use the battery and then it's done. Secondary cells, obviously better because we can recharge them. So let's take a look at some types of batteries. The first one is a dry cell. And as the name implies, there's not a lot of liquid. It's not technically totally dry, but there's not a lot of liquid. Generally, these are primary cells, so we can't recharge them. So here's a diagram of a dry cell. You can see there's really no source of water. They have this kind of paste instead. You can see this one's kind of this manganese and zinc type of reaction. Second type of battery, which is kind of the same thing as a dry cell, but slightly different, is an alkaline battery. So in strict terms, alkaline means basic or base. And so the base they most often use here is potassium hydroxide. And so by using potassium hydroxide, you can basically make a better battery. Most of these are still primary. Some are secondary, but most of them are primary. That's kind of why one of the reasons they warn you not to try to recharge a non-rechargeable battery is because you could break it open, and in this case, release that potassium hydroxide. So you can see the main difference between this battery and the previous one is the base, the hydroxide. Third type, lead acid battery. This is a secondary cell, so you can recharge it. Lead acid batteries are most often found in your car. So your car batteries is a lead acid battery. And as the name implies, it is actually composed of lead and acid. So that's why it's important that when your battery kind of is dead, that you don't just toss it in the trash, but that you dispose of it properly, because lead and acid are both bad for the environment, especially the lead. So there's a picture of that, and you can see the reaction there. You can see we got lead and we got acid. So this is a secondary cell. So think about when you're driving your car, the alternator is constantly charging this battery. We won't get into the particulars here. Next up, we have a nickel cadmium battery. This is a secondary type of battery, and this one's rechargeable quite a few times. And so you can obviously tell that the stuff used here is cadmium and nickel, hence nickel cadmium battery. This one can deliver a lot of power, but lately it's being replaced by nickel metal hydride batteries. So this is nickel metal hydride. A hydride is basically an H minus, right? And so these are rechargeable kind of thousands and thousands of times, and they're getting better and better. And then finally, kind of save the best for last, probably the one you're most familiar with is a lithium ion battery. And so if you think about where lithium is on the periodic table, it's very small and very, free to give up an electron. So this smallness is very good because it's very light, and so allows you to make very light batteries. And so this lithium battery actually works slightly differently than the other ones. So during discharge, so when you're using your battery, I don't know, to drive your Tesla or whatever, it goes from this lithium zero, lithium solid, to lithium plus, and then an electron, and then that'll release some energy, allowing you to drive your car. And then if you think about the reverse, when you're charging your battery, you're going to go from lithium plus, you're going to give it an electron, and of course that's going to take energy in to form this lithium solid. So there's kind of the charge discharge cycle here. And so lithium ion batteries are probably one of the most researched and most kind of demand for more research. There's still plenty of room for improvement. And it's, kind of a team effort, chemists, engineers, material scientists, all kinds of stuff. So you can see here is just the charge discharge type of stuff. When you're discharging, you're going from lithium solid to lithium plus, and when you're charging it you're going from lithium plus to regular lithium. One thing that you need for these types of batteries is a very porous material that your lithium zero can kind of just hang out in. And so the most often used materials here are graphite, which is basically just carbon. Some other uses are carbon nanotubes. So my research group did some research on carbon nanotubes and forming kind of better batteries. So on the left side here, again, we have lithium plus, and on the other side, we have lithium zero. So one way to store this energy is through kind of, the redox of just certain components. Another is to use a fuel cell. So the idea behind a fuel cell is to store energy in chemical bonds. So the most kind of popular example for a fuel cell is a hydrogen oxygen / water fuel cell. So during discharge, so when you're getting the energy out, you have H2 gas and O2 gas, or compress them into a liquid to form water. and a whole lot of energy. And then when you're thinking about charging this, what you're doing is water splitting. So you're taking a molecule of water, and you're splitting it up into H2 plus O2. And obviously that will take energy to do so. And so, I don't know, you have some kind of maybe green energy source splitting water. And then when the sun sets, you can turn on your fuel cell and you can get access to that energy back out. The cool thing about fuel cells is they can be scaled a lot better than a battery. So here's just kind of an example of a fuel cell. So you can see on this left, we have fuel in, and you can see it's H2 gas. We have this kind of electrolyte that allows H plus to go through, but does not allow the electron to go through. So instead, the electron has to go through here, and then you can put a load there to make it do work. It meets back with the H plus on this side, and then it combines with some O2 and the H plus, and then these three combo to form your water, which is a very stable molecule, thus releasing energy. So the cool thing about these kind of fuel cells is that they're relatively clean. You don't have to use water. You can use other stuff instead. And so you don't have to dig up a bunch of lithium, right? You don't have to, mine for a bunch of precious metals that the other batteries require. So that's kind of the main advantage of fuel cells.